to mic. Replace that with add buffer to mic. We save. Let's go. All right. So make sure it still works. Sound has to work is the thing. Sound should be smooth. Hello. That's good. That works. Yeah. So I'm pretty happy with that. Let's look at... Okay. So now all we have to do is change the width based on the power. That will be in our voice entity. So right now in our drawing code, yeah, we have a bunch of stuff. We could save the initial size, because there is an initial size. What I mean is, even when there's 0 buffers, there will be a little bit. I'll draw it in dark green. But there's this other extra bit that sticks out. You get an initial size of this much, and for every other buffer that gets added on, you get that much. So we need to keep track of that initial part. And we will need a variable to do that. We don't have any real variables. Oh, we have one. But we'll just say float initial y size. Yeah. Oh, would you look at that? There's already a start size. No, that's local. Yeah. So what I want is initial y size equals start size dot. Okay. And then I'm going to use this down here. Yeah. So when we draw stuff, we do all this bind stuff, but the actual thing that draws the rectangle is just this. Is that right? Yeah. You map the vertex pointer and the coordinates. Yeah, I think so. But what we can do is instead is after that first bit, we just translate on down. Yeah, so I'm going to say yeah, it's going to be different from here. Draw first initial size component, and after that draw each bin, each buffer separately. And if this ends up being too much of a CPU load, because those each second has 40 buffers, I think that's okay though. But if it is, we can shrink the quantization down a bit. Okay, so what we want to do is have a for loop, and we want to go over our buffers. So that's just, let me take out the input manager, we don't need that. So that way I can see two parts of the screen. Yeah, it'll be something like this. We'll just steal that. Yeah, so we go over the in buffs. Don't ref count them though. Instead we will... Is in buffs a pointer? What's this? Dereferencing in buffs. Ah, this is wrong. This is input. Buffers is our thing. So let's look for a slightly different one. Yeah, we want something like this. And instead of ref counting, we are interested in our average power. Yeah, average power. What do we want to do with that? Well, the maximum power is going to be 1. So for now, we'll just for now, we can just do something else, like if no, we don't do if. We just base the width based on that. So width's computed like this so far. Where is width computed? Yeah, we use a scale to do width. So instead of size.y, we will have our vector 3. What is it? Filter vec 3. Looks like they're using some different indentation thing here. And we'll call that seg size. Yeah. And we just say, yes, seg size dot z equals 0. Seg size dot y equals, we have a pound defined that already does that. It's height per buffer. Okay, height per buffer. Okay. Yeah, and we want exactly one of those per. One scary thing that might happen is if we don't translate it right. No, the translates will work fine because they're not cumulative. Yeah. There might be an issue with aliasing, but we'll see. This might give it an interesting texture as well. So buffers I, average power. What do we do with this now? Well, we do seg size dot x equals that, and this is just a value from 0 to 1, so we can just multiply by our normal size like that. So it'll be smaller than our regular size, at most the same, but that range is going to be controlled by the power in that buffer. Okay, so we take this, and at first I'm not going to worry about textures and stuff. I'm just going to copy and paste this. Yeah, I mean, this is not pretty, but we can refactor it once this works. The translate will be a little tricky. Seg size, seg pos. So the position is actually the hardest part. Yeah. Yeah, because we can assume that the top is y with a low value. Okay, so we do seg pos equals pos. Yeah, seg pos equals pos. And then after that is when we get tricky. We have to do seg pos dot y equals. So firstly, the x value is not going to change. That's always going to be in the center, but the y value will change. Okay, so we want to move to the top, and that is going to be size dot y. We just have to subtract size dot y. From, okay, so we want to subtract size dot y, and I'm doing a plus here because we also want to add a little bit for k height per buffer divided by 2. Yeah, and this is actually going to have to go here, because this is going to be I times k height buffer. I see. Yeah, it's going to be I. Tricky, huh? Is it I? This is hard. I gotta draw. Okay. So something like this. Oh yeah, I have to take care of this minimum size. This is the free part you get for free for 0 buffers. After that, it's segmented up smaller. Oh, that was a totally straight line that I drew. Right? I don't know if I can ever do that again. But yeah, the position of this one is right here in the middle of this small guy. So you have to subtract that initial size, and then also half of that. Whatever, this is the fixed width per buffer, height per buffer. But for the next one is interesting, because you subtract the entire thing and then half of that. And for the third one, you subtract 2 entire things and then half of that. So it is I plus 0.5, like that. And you also have to add k, what was it now? The initial thing, what was that called? Initial y size. Yeah. Yeah, there it is. Okay, and all this stuff goes within the for loop. It's not actually too much when you look at it. So, doing this, what was I about to say? Oh yeah, I have to change these to use seg size.